So you want to throw out Neal and Q.
I don't know if I can throw out Neil.
It's like a bouncer marshal just standing at the front of the party and just not only not letting people in, he's going in and kicking people out. Welcome to another episode of ArrayCast. I'm your host, Connor, and today with me, I have four different panelists. We're going to go around and do brief introductions before we hop into a couple announcements and then our topic for today. So we'll start with Bob, then go to Stephen, then go to Adam, then go to Marshall.
I'm Bob Therriault, and I am the J enthusiast, and I'm working like crazy on the J Wiki. And in the next couple of weeks, and I may put something in show notes, in the next couple of weeks, I may have something to show people because it's coming along. It's kind of interesting. And I hope it works out.
I'm Stephen Taylor. I'm an APL and AQ programmer.
Adam Butzewski, full-time APL programmer and teacher and lots of other stuff.
I'm Marshall Lockbaum. I'm a former J programmer and dialogue developer, and now I'm the BQN creator.
And as mentioned before, my name is Connor. I am a C++ software developer and a research scientist at NVIDIA, but in my free time, I spend basically all of my time learning and researching array languages. And I guess I do that a little bit at work now as well, too. So for our announcements, I believe we have four of them. We'll go to Adam first, who's got two announcements, one which is very exciting. I guess both are exciting, but one is especially exciting, and I'm excited for the listeners to hear about it. And then we'll go to Stephen for one more, and then Marshall for a final one.
Okay, so by the time this comes out, I'm 99% sure that the first recordings from Dialog 22 user meeting will be out. Looking forward to seeing those myself, as I couldn't make it there. And we'll include links, of course. And then I'm starting an APL podcast together with Richard Park. And we've just been recording the first episodes. It should be available by the time this comes out as well. And should be available both in video and eventually at least in audio form as well.
As executive producer on this podcast, I want to know what two of my panelists are plotting here.
A rival podcast. Actually, that's true. How much of a rival podcast can it be if it's just the same people half of the time, at least? I guess you and Rich aren't on at the same time. So we'll call you our rival podcast, but really, it's not like a true rivalry.
It's like a kid brother.
No, I'm envisioning it as very different than this podcast in that it's very much inspired by what Connor and Bryce are doing on ADSP. Just Richard and I getting together, discussing either just some ideas or responding to something that somebody has written or said or done or whatever. So I don't think it'll be much of an overlap there.
Well, maybe if you develop some multiple personality thing and start disagreeing with what you said on the other podcast, then we can get the rivalry going.
Anything I say on this podcast should not be taken as my opinion on that other podcast. So go listen there.
Should be the opposite of your opinion. On the other podcast, you think the other thing.
It's the anti-Adam.
That would be pretty cool.
Hi, I'm Anti-Adam. I work for Anti-Dialogue, where I teach anti-APL.
That goes left to right, right?
Yes.
So when is the first?
When is it coming out? I suppose it will be available online by the time we release this episode. So,
all right,
we've already done the video and audio editing, so just need to upload it and make a site and whatever.
So I'd say pause this podcast right now, but I'm not going to say that. Finish listening to this episode, and then go and listen to Adam's. Are you allowed to drop the name of the podcast?
Yeah, it's not a secret. Can you guess it?
APL Cast?
If it's not a secret, how do we... It's not a secret. You guess it.
I'm going to go all the way. I call it by a 9-letter abbreviation or initialism.
Oh, this sounds confusing.
APL, notation as a tool of thought.
Yeah, all right. I was getting there.
What? That seems like Apollo not a knot or something. What?
Who says you can pronounce the initialism? I didn't say that.
I thought I thought we were playing a game here, where I was supposed to figure out how to.
I guess you could call us the hosts. You could call the Apple Tots if you want.
All right.
This sounds good.
Okay, well, we will definitely have links in the description for that. And yeah, definitely excited. I always love podcasts. I was saying that before when Adam mentioned it. I got pretty excited, and I will definitely be a listener. And yeah, we'll try and get some kind of rivalry going on. And this is just the beginning. I'm sure there's a listener out there now thinking, what? There's now an array language podcast, an APL podcast. And so now soon there's going to be a Q podcast, a BQN podcast, a J podcast. I can't wait. The array language cinematic universe of podcasts is coming, and it's going to be great. All right, we got two more announcements. We'll go to Stephen and then to Marshall.
Right. This is for everybody who's trying to learn or improve their Q by themselves. There's kind of a gap in the resources available for solo students, and it happened because for the first 20 years or so of its history, Q is pretty much confined to teams working in Wall Street investment banks and to 2 or 3 consulting firms. So if you were joining those firms, you get an introduction in how to use the language, and then you kind of learn from the people around you. But if you're a solo student, you can find the initial introductions online, but there's not much in the way of study resources if you're trying to improve by yourself. And this issue was raised by a voice in the Vector Dojo quite recently. So we started pulling together some puzzles, solutions, relatively fairly simple stuff, Project Euler and whatever, but not just the problem and a raw solution, like here's a solution, because nobody actually needs the solution itself, but a discussion of the solution and some alternatives. And you can find this stuff on GitHub. It's all on open source. It's at cubists/studyq. We'll have it in the show notes. And please do enjoy it. Please contribute more. We welcome just raw solutions, but as said, we prefer to see discussion of how the solutions developed. So you find your way thinking into this, because the problem that we're trying to address here is the challenge that people who are coming from C-like languages face when they're trying to develop vector solutions.
Yeah, this is super useful. And it looks like there are multiple contributors to this repo. So as you mentioned, if you're listening to this and like I'm looking at the directories in the repo, and there's Advent Code, LeetCode, Rosetta, Euler. So if you have any solutions of your own, or as Stephen mentioned, sort of articles discussing that, I'm pretty sure if you go and add links to that into this repo, that would be totally welcome as sort of a go-to source to find different Q out in the wild, which is, yeah, definitely a great resource if you're looking to learn. All right, Marshall, last announcement.
All right. Some news regarding the tooling for BQN, which is maybe a little early, but Zyma, who is the creator of CBQN, if you don't know, has been busy working on integrating that with a command line REPL tool called REPLXX. So currently what we tell you to do is use RLWrap, which takes, any executable and just wraps it in a simple command line that can do, that works like Bash. It has like history, and you can enter lines and you can edit things. But it doesn't have nice stuff like syntax highlighting, which a lot of people have asked for. So Zyma has been working with this REPLXX tool, which integrates a little more closely with the language, and it gives you syntax highlighting. He's added completion for system values too, and I think names in the program as well. So currently, as I'm saying this, what you do to build it is you have to clone REPLXX into your CBQN repository, and then you build with an option that says, and you check out the REPLXX branch, which is not merged into the main branch yet. And then you build with an option that says use REPLXX. And then you have your BQN executable. If you just run BQN, has a REPL built in that you can use normally, and it has syntax highlighting and all that stuff, and tab completion. So that's pretty cool. And yeah, hopefully it'll be more officially supported pretty soon. So you'll have it in the main branch, and you'll say, I want to build with REPLXX, and it'll do all the work for you and figure out how to get you running with REPLXX and download the code if it has to.
That sounds super neat. I'm trying to think of the REPLs that I know of that have syntax highlighting. And honestly, the only one that comes to mind is IPython, which is a super, super nice interface for anyone that's used it before. And I do know a few, like the Haskell.
Doesn't Node do it?
I don't do a lot of JavaScript programming, so I do not.
Yeah, I know Node has the intermediate results, like it shows results as you type, which is pretty good. I don't remember if it does highlighting actually.
Yeah, and I know like the Haskell interpreter, it does error highlighting, like it'll sort of highlight things in red, but it definitely doesn't have like syntax highlighting throughout, which is really nice. So yeah, definitely if you're using BQN locally, this sounds like something to check out. All right, 4 announcements out of the way, which brings us, I mean, if you're listening to this episode, you probably read the title, which means you've been eagerly awaiting this conversation, which is part 2 of our What Makes a Programming Language an Array Language, which I believe we're going to title Iversonian Languages versus Array Languages. So this is, if you haven't listened to part 1 of this conversation, it was 2 episodes ago, I believe. We'll put a link to that at the top of our show notes. We will assume that most folks, or all the folks, have listened to it already, but I would definitely go and listen to that one first because it's going to probably inform a lot of our discussion today. And I guess to recap briefly, at the end of that episode, we had screen shared and I had made a small little Venn diagram to which I then went and made a nicer one in PowerPoint and tweeted it out. And since then have added a bunch more things, which I think locally we'll try not to refer to this a ton in detail and spend the next 60 minutes talking about it. I think what we do want to talk about, though, is sort of diving deeper down into what are the enumeration or delineation of things that make you fall into the Iversonian small green circle in this Venn diagram versus the larger superset circle, which is a red circle called array languages. And inside the Iversonian languages are the languages J, APL 360, which is we use the green apple logo for that. In this case, Dialog APL, BQN, Nile or Nial, I think I'm pronouncing that correctly, the second one. Remora, which is a research language that was done by Justin Slepak. And then the KX logo stands for K and Q. And then outside of that circle and inside the array languages, there's R, NumPy, Julia, MATLAB, Fortran, single assignment C, and DEX. And so I think before
I'll claim that the Wolfram language or Mathematica belongs in that circle as well.
Yeah, I've been meaning to change that because Adam's pointed out to me, I think twice now at least, that
this is the third time.
They've got,
but who's counting?
Yeah, rank aware functions that conform to the leading axis theory. So it should be in the red circle, but I spent so much time because this Venn diagram got so complicated that I've just been kind of deferring doing that. But yeah, Wolfram should potentially be in there. And even Futhark should potentially be in the red circle.
Yeah, well, so following the Futhark episode, we do need another circle for which ones we've discussed on ArrayCast. Because Trolls says that makes them into array languages.
Yeah, we should. I don't know if it needs a circle because that'll get too complicated, but we should put like a little emoji, happy face or something up in the right corner. But yeah, the last thing I'll say before I hand it off to the panelists is that we should try and, because I think that was one of the things is when we started in the 2 episodes ago talking about this, is that this isn't necessarily a list of things, or maybe we can discuss what we really want, like the definition of this criteria to be. It's things that we are expecting the languages in the green circle to have, but just because actually, I didn't think about how I'm going to word this. Just because you don't have it, it doesn't make it. So like, what was the thing is that just because you have it doesn't make you an array language. That's what I'm trying to articulate. Yes. So I think the thing we started talking about 2 episodes ago was a literal syntax for rank 1 arrays, aka vectors. And then that was something Stephen pointed out. And then I think because of the confusion, some people, or I can't remember who exactly said, but like C and C++ technically have a literal syntax for arrays, but that doesn't make them array languages. So these are a list of things that we are expecting array languages to have. And just because a language out in the wild has this one particular thing from the list doesn't make them array language. But yeah, so it's a list of things, 2 lists of things, I guess, things for array languages and things for Iversonian languages. All right, I'm done talking. Who wants to go first? All right, Adam.
I'll actually maybe add another language to the list here, but it might be controversial.
Uh-oh.
You'll fall off your chairs here. Texas Instruments Basic, or TI Basic.
Not the way I used it.
I've seen that on the Wikipedia page that they do list it as a array language, but
They do? Oh, really? Okay. I didn't realize that, because if you look at, say, the documentation for multiplication, then it will say value times value, or value, I guess, is a number, or list times value, or list times list, or I think also value times list will work. So it does do that kind of thing automatically with no extra syntax at all. It just auto maps. And I certainly have used it as an array language, as a poor man's array language.
Oh, when I used it, I didn't know what an array was. I didn't know what a for loop was. I thought you had variables for every letter, and that was all you got, because it has no multi-letter variables. And I wrote my code with go-tos in the variables. And when I needed to store a lot of data, I would store it base 10 and packed into one variable.
Ouch. I actually have a fun anecdote of using TI Basic as an array language. When I was in high school, gymnasium, if you want, we had a philosophy course, and one of the things we had there was formal logic. And then we had tests on that, and I asked if I could take my TI graphing calculator with me on the test, because at the time, at least, I don't know how it is today, in certain subjects for certain tests, you were allowed to take calculators with you, in other subjects not. And nobody could find anywhere where it said anything about bringing calculators along to your philosophy tests. So they seemed to be okay as long as I cleared the memory of it in advance, so it wouldn't like store information I need to know by heart in it. So I did that. And so for the formal logic part of the test, we were given some crazy long statement about Flash Gordon or something, like it was raining, I don't know what, and we were supposed to evaluate if it could possibly be true or not. Instead of trying to figure this out by hand, which would be hard, I just looked at how many variables there were, and then created lists of 2 to the power of n with all the different possibilities as a sort of binary counter type thing. And then unfortunately, it's only normal arithmetic that works with these array things in TI Basic, but you can just define and in terms of multiplication, which is just multiplication. You can define or as not the and of the nuts, right? Sorry, whatever.
You can actually do multiply minus add too, I think.
Yeah, well, there are many ways you can define it, and then not is defined as one minus of the value, and that all works with this array stuff. And so I wrote it all up like that as one giant formula, and pressed enter and got the answer and went on to the next question. Saved me a lot of time on that test. So definitely can do array. That is array programming, right?
Yep.
All right. Well, I mean, I think the moral of that story is if you can bring your graphing calculator to what kind of course was it called? A something?
It's philosophy.
A philosophy. I mean, I did take a philosophy course in university, but I don't think I have my graphing calculator then. But the point is, if you are in first year university and you have a logic philosophy course coming up, bring your graphing calculator and learn array programming, and you can save yourself time. Hopefully. As long as they don't ask you to show your work, in which case you'd probably need a more complicated program. All right, back to the lists of things. I'll start off, seeing as I'm going to say this at some point, so I might as well say it now. I've been doing a lot of studying of all the languages, and I think one of the lowest criteria, and it actually sort of separates quite a few of the languages, is that the language has to have a scan. Then you'd think, well, don't all languages have scans? Wrong answer. So MATLAB does not have a scan. Doesn't even have, I think, a generic reduce. MATLAB does technically have the ability to pass functions around, I think, with an @ symbol, but it's not really that ergonomic. But there are...
Yeah, but what do you mean by generic reduce?
A reduce that can take a binary operation.
Any or just as arithmetic ones?
I mean... I will say, because APL 360 only took the built-in ones.
Yeah.
So anything that can do like the basic set of min, max, etc., multiplies, divides. Ideally, I'd like to see support for sort of custom ones. But I'm not even talking about, so I guess that was the answer to what's a generic, but just like the ability to reduce and scan. And I think that already rules out several languages. So MATLAB, like I said, doesn't have a scan. And I'll probably give a talk at one point called this. But I think even higher bar is to be able to do a minus scan.
Yeah, well, see, I'd say really, I would think it's still an array language, even if it has hard-coded plus scan, min scan, max scan, because I think that's about all I ever use, other than doing like more complicated functions and using scan for control flow. But that's not really an array programming thing.
Yeah, so if you have a sum and a max and a min function, it just takes a list and automatically.
Yeah, if you have like cumulative sum, cumulative minimum, cumulative maximum.
Really? So you think the bar?
I think that would be a comfortable array programming language still.
Really?
And MATLAB has that. It has comprod and commin and so
Yeah,
on.
terrible names. But I mean, so that's the thing is that I have these small list of problems that I'm trying to solve. And one of them is the maximum parentheses depth. And that uses a minus scan after it does the outer product.
That's a reduce.
Or sorry, minus reduce.
You said plus scan.
Yeah, that's true. I did. But I said minus scan, but in this case I also mean minus reduce, which
But you're only using minus reduce on an axis of length 2, which is really not a real minus reduction. It's just splitting it's basically just taking a binary operation and using it with the syntax of a single argument operation, right? You're taking the 2 rows of a table and use them as the 2 arguments in a subtraction that's vectorized.
How do you do that without a minus reduction, without having to separate your 2-dimensional list into 2 1D lists and then...
Well, that's exactly how you do it.
Well, you'd have to separate it. But like if you had a pattern, like BQN's pattern matching syntax makes that not too bad, because you could write a function that does it. You'd have brace, and then you'd write a square bracket list A comma B, and then colon. So that would destructure the argument into cells A and B. And then you do colon A minus B.
But that's essentially the same as manually assigning it. Right?
Yeah.
That's just using the built-in syntax.
But I think that gets that captures the entire array part of the computation, right? Like you're saying, because the reduction only works on 2 elements. So it's not like a big array reduction. It's just it happens to go between the cells.
And just for the listeners following along at home, what we're talking about here is, I believe, and correct me if I'm wrong about this, but essentially you set up one line which will be right parentheses and one line which will be left parentheses, and match them to those. That creates ones and zeros for right separated from left, and then you subtract one from the other, and you end up with a series of ones, minus ones, zeros, and then you do a reduction across that, added up.
Plus scan first, and then do a max reduce.
Plus scan across that, and then it gives you the different numbers, which gives you your depths of parentheses.
The key thing we're discussing is that if I have a 2 by n matrix, can I combine those two with a minus binary operation? And Adam and Marshall are arguing, well, I mean, that's
yeah. Well, I've also seen this written a lot of times as just x equals open parenthesis minus
right.
x equals closed parenthesis.
Yeah, that's true.
In K and Q,
let me jump in here because Q recognizes this, and I suppose implicitly K as well, the distinction. So you've got the reduction using the over iterator. But if you just want to separate out the arguments of a function, which in APL might be dyadic, but in Q can be up to 8 arguments to a function, you can take a list or vector of the values, and you use the dot operator to apply your function to it. So a function which is takes 5 arguments, f, you can say f dot and then a list of 5 arguments. So for your example of 2 elements, it's trivial and it's neat to do that. and we discourage people from using reduce to do it, because reduce implies something more general along a list. Whereas when you see the dot, the apply operator used, you're just doing it for two arguments.
Yeah, that is really nice. Does that correspond to a combinator or no?
No, because taking an array element isn't something a combinator can do.
So is it in the case where you have a 2 by n matrix, is it taking the first column? So instead of doing like a column-wise minus reduce, do you just spell that minus dot?
No, we use leading access. So if you have a 2-row matrix, you could pass that as dot, and they'd be the left and right argument of your function.
Really? So minus dot is how you would spell it?
I'm sorry?
Or sorry, like so you're saying because it's leading axis, if you just have a binary function and you pass the dot to it, it'll take the first row as your first argument and the second row as your second argument. So minus dot is literally how you spell subtracting the second row from the first row.
Yeah, there's a nice example of it in a solution I was putting up on StudyQ over the weekend, where you set up an initial state. You set up an initial state, which is a list with 2 elements. The first is the first is itself a list, and the second item is an index, which you're going to try. I think the problem was I wanted the last item in the list, which passed a particular test. So my initial state is the list and the index of the last item in it. And then the function being iterated simply increments the second item of that list. So decrements, because we're working from the back. So I go doody 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 doody, going from right to left along my list. And I'm using the while construct of the iterator. So the whole thing stops as soon as you find something that passes the test. And what it's going to return is the original list and the incremented or the decremented index, pointing to the item that passed the test. The leftmost element of the whole expression is simply dot, then in square brackets at, which is the index at function. So it takes that list and the index and indexes the list, and bingo, there you've got the item that was the last one to pass the test.
But you need square brackets for the dot, right?
You do in that case, yes.
So you can't, because I just tried in K writing plus dot 1 2, putting a space between the dot and the 1 so that it wouldn't parse as 0.1, and that failed. But if I write dot open square bracket plus semicolon 1 2, then I get 3.
Can you put the plus in parentheses maybe?
Yeah. I think you can use it. You can use the infix syntax. You should be able to write at space dot space, and that'll do the indexing.
Yeah, for indexing. Now I'm not doing indexing, I'm doing plus.
No, not doing it.
So you say Marshall, you said putting parentheses around the dot would work?
Yeah, because that should turn it from a function or from a verb into a noun.
Oh yeah, that works.
And if I recall correctly, this dot technique was used in another Q solution that we discussed in an episode that I won't remember the number of, where Stephen was explaining, I think, if my memory serves correctly, how to take the range between 2 numbers.
Yes.
Yeah.
And you have a blog article, and I remember reading that blog article and staring at it and being confused, even having just had the conversation with you, being like, what's going on here? Because you can't do that in any of the other array languages. Like, you have to do the reduction in order, the trick of a 2-element list and doing reduction. And I think at some point upon reading it and playing around with it, I figured it out. But now that we're talking about this again, it is jogging my memory that, oh yes, that's right. We discussed a solution that used this trick that I read and looked at and learned temporarily, but then clearly it's been pushed to the back of my memory. So yeah, we'll link that article as well, because I think that's a really good example of a use case of where it's like the bread and butter thing that you want to reach for in that case. All right, so to get back to the list of things, so it sounds like, though, essentially, we do not have a unanimous agreement that a scan or even a reduce, generic versions of those are not essential for being an Iversonian array language. Even just having hard-coded with no generic reduction in the background that you can access.
Well, definitely not for being an array language. For being an Iversonian language, I think if you don't write, like sum is +/, then that's a pretty strong point against
So
you.
that's what I was after. That's what I was talking about, is what we're talking about now. So I think we kind of have talked about in the last episode what an array language was, and that's we've got all these languages in these circles, and we've got a little asterisk. We need to decide officially, is Futhark in the group or not. That's the red circle, the array language group. But now we're trying to figure out what delineates Iversonian languages versus array languages. So this is the thing, the generic reduces and scans, and specifically sort of the ability to do a minus reduction or a minus scan. I think in order to get in the Iversonian club, you have to show up at the doorstep with your generic versions. And I thought that's what you were saying, is that the hard-coded ones are good enough, which is, I would say that
they are for array programming.
Okay, but
I mean, I think it's expressing it as an operator is much nicer. But like if you're writing code that really is just dealing with big flat arrays, then for scans, plus min and max, I think are really all you ever use. For reductions, there are a few more. Like you might use a product and probably some other stuff.
Well, minus scan is, depending on how it's defined, is useful, which is why Iverson defined it that way.
Rarely.
Division scan.
I mean, I consider...
Yeah, alternating series.
Yeah, but also if you don't have a minus scan, you just write like -1 to the power of iota length and multiply that before you do your plus scan. So
or raise to the power of that before you do your
and a lot of the time you already have an exponent, so you actually just want to make the number inside the exponent negative.
I consider scans, I mean, we should dedicate a whole episode to scans, but I consider the dialog APL and J scans broken, and Q and BQN are the only ones that get it right. And I think Nial also adopted APL's version, because sure, it works nicely for continuing fractions and what's the other one called? What's the minus one called? Alternating sums? Is that what it's called? Something like that.
Alternating sums or alternating products.
Sure, you get those patterns, but like in one of my favorite problems, the maximum consecutive ones, it breaks because of the fact that you're doing repeated fold writes. You need to be doing it from left to right in one pass. And so, yeah, it breaks my heart that I'm sure, like Marshall said, in rare cases, it's what you want. But
yeah, well, and even for stuff like continued fractions, there's a representation that uses a matrix like internally that you can compute all the convergence to the continued fraction with a left to right scan, and then you get it in linear time instead of quadratic time.
Right.
So you have to do more math for that. But still, it's like the ideal form is expressed in terms of a left to right scan.
Right.
But J has now that generalized F with lots of dots and colons and stuff, right? So you can do.
Yeah, I'm sure the right thing is in there somewhere.
Yeah, just figure out.
Yeah, so the fold is a bit confusing, but yeah, I believe it is. And the other thing I'd wonder about, does your algorithm break for Connor's consecutive ones if you do the reverse scan in J? Because you can do it the opposite direction. Does that?
Well, no, it doesn't. The number of consecutive ones is the same forwards or backwards. So yeah, J does have. I think we've kind of glossed over what J does, but J doesn't actually have a scan operator. Even it has a prefixes operator and a suffixes operator, and so you write the APL scan as reduce prefixes, but you can also write reduce suffixes, and that saves its results. So, right, the problem is that an APL reduction goes right to left, and J doesn't have a left to right reduction, except I guess in the fold family of functions that are newer. So J doesn't have a left to right reduction, but it has both prefixes and suffixes operators. So if you do the right to left reduce with a suffix operator, then it's allowed to save all the results in between. And then it can run in linear time.
Interesting. Is APL's reduce left to right or right to left? I always thought it was left to right.
No, it's right to left.
Really?
In principle. I mean, if it understands that it can do it left to right, then whatever. Lots of footnotes there.
Oh, because I recall doing a test once that I thought confirmed that it was going left to right, which is why I thought it was even more confusing when their scan was repeated right to left scan. But you're saying in general it's right to left, but there's some optimization sometimes where it ends up going.
Well, there's like one case in dialogue where if you're doing a plus scan where the result consists of a single element on floating point numbers, then it will do it. And I mean, the only difference here is the way the rounding error goes. So for most lists of numbers, it's a very small difference. It's just like a little precision error. But yeah, those plus scans go left to right, and everything else I think goes right to left.
Okay. All right. We're going to step back a couple steps because we're not even close to building our list here. So, what? So, I said we weren't in unanimous agreement, but then it sounded like there was confusion. People thought I was talking about array languages. So I was talking about minus scan, minus reduce, and sort of generic reduce and scan being something you need to get in the green door, the Iversonian language door.
I think it's a generalization of it. It's not whether or not you can do it or whether or not it has a name, but the fact that it's thought of as a single concept, that's what makes it Iversonian.
Well, I mean, so we have to reckon with the fact that Ken Iverson's J decomposes scan into two concepts. And I actually went this way.
Yes, but it's still a generalization.
Yeah. But it's a different one. It's not the same one that's used by the original APL.
That's true.
But I think we have to allow that the languages have evolved, right? So that what the original APL might have done has changed as the languages evolve. That doesn't mean that a language becomes non-Iversonian because it evolves.
I mean, it might.
Is Iverson notation is surely not an Iversonian language, right?
It has a scan and all that.
It doesn't have generalized multidimensional arrays. It doesn't.
I mean, so the book, A Programming Language, doesn't use them, but it doesn't really preclude them, does it?
It has different symbols for the length along the first and second axis of a matrix, instead of having a single symbol for the length along all axes, which means there is no definition for lengths along further axis. You can't access them in any way.
So yeah, it would have to be extended to deal with rank 3 arrays. I mean, you just pick the next Greek letter after nu, I think.
All right, so clearly my criteria is not the best one. Let's go around before even discussing it, and you gotta think on your feet. If you had to choose one or two things, you're standing at the Iversonian language party of the century. All the Iversonian languages are invited, and the array languages want to get in too. But you've got your list, and you got a couple questions you want to ask them, and they don't get in based on these questions or criteria. Does anyone have? All right, Bob's got his hand up, and everyone can think in the background. And then we'll try not to discuss until we go around, unless if you can't think of one. Bob, go ahead.
So, sorry, did you want me not to say what I think the distinguishing?
Oh no, we'll say, and then because I know what's going to happen, because that's what happened last time. I said something, and now we are 30 minutes later, and we haven't even used that criteria that I suggested as if it's on the list. So let's try and generate a list, and then we'll come back and discuss the items on the list.
Okay, so I would say to begin with, was your language originated by Ken Iverson?
Yeah, exactly.
Because to me, that's, and then on top of that, to even distinguish a bit more, is it what I would refer to as mathematical in origin? So in other words, it's based almost axiomatically that you start with, you're not trying to add on things to the language to allow it to do its operations. What you're doing is you're taking foundational elements and putting them together to give yourself a computer language. And to me, that's what an Iversonian language does. And then the questions I've got is whether that corresponds to Nial and Remora, because I'm not sure too much about them. I don't know them very well.
Interesting. So this is actually, so we got,
Well,
wait,
so for the first point.
wait, we're not discussing yet. We're going around generating. See, I told you it was going to happen.
Well, I was going to discuss the parameters of our discussion.
So that's the thing is, I was going to say, it sounds like we got two lists here. We've got a list of questions that if the answer is no, you don't get to come in. But it doesn't necessarily mean you get in. It just means you get rejected. And then there's another list, which is what Bob just added an item to, which is basically like showing a VIP badge. And you're like, hey, Ken created me. I'm going in. Doesn't matter what the list says. Ken created me. I'm going through the door. And you go, okay, yeah, he's got the VIP badge, which would mean, so J, APL 360. I guess Dialog APL, even though technically it wasn't created by Ken, but it's a re-implementation of the exact same ideas with twists and turns here. So those three get you VIP badges. And does like Nial count? Does Remora count? It's like, well, those weren't created. So yeah, we could discuss that. So I guess you can add criteria. Bob has implicitly created a new list. Feel free to add to that one as well if you think there's a criteria that gets you through the door no matter what else is in the language. And Marshall, do you want to say something?
Yeah, well, I'd like to propose for this discussion that we're not allowed to look at the history of the language. We have to just look at the design of the language, what it does, and say purely based on that whether it's Iversonian or not.
So Marshall's invalidating Bob's.
Because I don't think it's too interesting a discussion to say, what does it mean for something to be an Iversonian language? Well, if Ken Iverson created it, I mean, that's a valid definition, but it's also not really a definition you can discuss because you just say, well, yeah, I mean, I guess we're pretty sure which languages Ken Iverson created.
I did add the second criteria, which to me is the important part, where it's mathematical, that you're building from an axiomatic base. And then that raises a discussion about whether building it up that way disqualifies the earlier versions of the APLs. Because they may not have got to that point before they evolved.
All right. I will keep Bob's criteria as like a shaken... What's that restaurant? In-N-Out. I'm thinking of Shake Shack. It's like an In-N-Out secret menu item where you can get like peanut butter on your burger. If you whisper the right incantation to, the individual letting you into the party, he'll lift the page and say, oh, that's right. You can come in because you were created by Ken. But it's not on the first page. It's still on a secret list though. All right. And the mathematical notation part, we definitely will keep on to discuss. Adam, Bob, Marshall? Wait. I just said Bob. Steven. I was like, something didn't sound right there. Steven, or did you raise your hand to?
Yeah. Implicit iteration on the primitives. That's the first. A second is a vector notation, as in our earlier discussion. You've got to have a way of doing vectors, literally. And scan reduce, as you were saying.
And so those are all on the original list. If you can't answer yes to those three, you get turned away from the party. Mm. Okay, I like that. I won't say anything, though, because we'll discuss in a second. Adam and Marshall, have you got your answers ready?
I would say if it's at least an attempt at a generalization of traditional mathematical notation, then it's Iversonian. Meaning programming languages kind of trace lineages back, and the lineage has to be traced from. I know Marshall said we shouldn't look at the history, but I'm not talking about chronological history. We're talking about notational history.
Yeah, but you can't just say like the criterion is it's similar to this other entire set of school of thought. You got to like name one or two.
Yeah,
features.
but I very much see it as like a generalization, especially of linear algebra. Right? It's taking linear algebra and distilling it out to its very essence and generalizing.
All right. So if you're at the party and Algol comes to you and says, oh, yes, I was based on linear algebra, what do? Do you spend an hour arguing about like what aspects of linear algebra are and are not represented in Algol? Or?
No, we were not arguing about these criteria. I'm saying this is required for it to be Iversonian. That's not necessarily sufficient.
But it just doesn't seem like an actual criterion to me. Like, how do I apply that to the language Algol? Because I mean, if you're asking, does algol have reductions? I don't know. I don't think it does, but that's a yes or no question. That's pretty easy to resolve.
But does algol attempt at being a traditional mathematical notation generalized? I don't think so.
When you say notation generalization, like, do you mean, like, when I hear that, I think of J, APL, and BQN, like the languages that use symbols, basically, like either digraphs or Unicode characters. Is that what you mean by like generalized notation? Or like, can you have I
mean, that helps, I would say, but it's not, I don't think that's necessarily necessary. But they have symbols, you could say, not necessarily glyphs, but it could be names for things as well that represent things you have in traditional mathematics, but they have been generalized to do more. Whether the generalization is by collapsing multiple things into a single notational thing. For example, reduction is a generalization of the capital Pi and capital Sigma and so on. Or whether it is a decomposition into constituent parts for generalization, like the inner product is a generalization of the plus dot times in APL terms instance of it, and so on. And you could say even mathematics generally deals with numbers and lists and sets and matrices, and here we're generalizing to any rank or even nested stuff and so on. It's taking these core concepts, and I think those can be identified, and generalizing them, distilling them out to their pure essence, and then expanding on them like that. I think that's a necessary requirement for something to be Iversonian.
I can see why Marshall is definitely pushing back a bit, because then, yeah, while I'm listening to that, I'm thinking of Haskell in my head. It's like Haskell.
Yeah, I think you've got some hidden circularity in that what you think of as the pure essence is what APL thinks of as the pure essence. But like, for example, I mean, the base function is pretty, it's a very compound thing. I mean, why isn't that distilled to its pure essence?
That doesn't mean there can't be add-ons. Certainly there can be more things added, but it has to have that type of aspect. At least that's what I think. I mean, we can argue afterwards.
Yeah. Okay, so we've got Adam's generalized notation tied in with sort of mathematical historical notation. Last but not least, Marshall.
All right. Yeah, I think I've got mine together.
All right.
All right. First, I think for being an Iversonian language, the syntax is very important. You have to have a syntax with where your functions are prefix or infix functions. So they're applied to one argument on the right or an argument on the left and the right. And I mean, maybe if you take that and flip it around, so you're going left to right, I might accept it. But even that to me is kind of questionable if you're saying it's really Iversonian. I think probably it should use symbols for most of the functions. It should at least have, some array functions that are represented with symbols. Because that's really the distinction. Like nearly every programming language has some symbol operators, but usually they're just arithmetic. So if you have array symbols as well, I would say you need at least some of those to be an Iversonian language. And then in terms of the functionality, I mean, this is not a complete criterion, but I think having, I think outer product is pretty important for array languages. So having a way that's simple to, pair every element of one array with every element of another, pairwise, in addition to having like the corresponding map that's just each, and scalar. Well, scalar extension is really a kind of outer product, so that I'm not sure is even necessary.
Yeah, that's a good one. The dual map, if you can call it that, the one that maps over both right and or both.
Well, and it's hard to talk about because in the wide programming world, there's really not a name for this kind of map. I think Jay went with table, which describes what it does all right, but it's awkward grammatically is the real problem with it. But yeah, this idea of I want to pair every element of the left side with every element of the right side, all the different pairs, and get that out as an array structure, not just as a set.
And I think Jay's table was because of, multiplication tables or addition tables, and you get the same result.
Yeah. Iverson explicitly said that, definitely.
All right. Before we hop into, I feel like there's going to be a part 3 to this now, seeing as we're like close to the hour mark already. Before we hop into sort of freeform discussion, so let me recap what everyone said. I didn't even put my own name on the list. And technically there's 2 lists here. So what I said was reduce, scan, which Stephen already said. And I should stop typing because it's going to ruin the audio of this. So I said reduce, scan, generic reduces and scans, and then also a minus reduce and minus scan, because certain languages have reduces and scans, but then the minus doesn't work. Bob, you initially said created by Ken Iverson, which we put on the secret list, and then mathematical notation, like it's an attempt.
Yeah, I think actually Adam actually expressed it better than I did, but I sort of go along with his, that it's origination in the language has to do with original mathematical notation, and it's extended itself to be more general beyond that. So you can do the same sort of things with characters and different things, as opposed, and this is where I think it gets interesting with K and Q, where Arthur was bringing Lisp into the equation. So you've got the sort of the mix of the two, and I think that still makes K and Q Iversonian, but now they have this extra flavor of Lisp in them, which is interesting.
Yeah, that is a good point. And so it's good that I got you to rearticulate that, because then it sort of simplifies it, is that Adam's and Bob's overlap or almost the same thing. So Adam will skip Stephen, who was second. Adam was the generalization of mathematical notation and tied in sort of with the historical evolution of those symbols. Stephen's was implicit iteration, number 1, number 2, literal vectors, and number 3, reduce and scan. I think I got that right. And then Marshall's was very interesting. Prefix and infix for unary and binary operations. Mainly symbols for a lot of your operations. And then outer product, or the ability to do sort of the pairing of 2 different arrays.
Yeah, so the second one I think I would change to symbols for array operations is really the big thing. I wandered around a bit, but... Mainly
symbols for array operations.
And I think I'd like to tack on, because we haven't mentioned it, I think like a compress, or K has where, so some way of filtering out elements in array based on a Boolean, based not on a function but on a Boolean array. That I think is another really core aspect of APL.
Interesting. All right, so I will kind of play moderator here and we'll skip around. So I think two of the most, well, so do we all agree with Stephen's entire list? Because I do.
No, I don't.
I thought that was going to be easy. All right, we'll come back to Stephen's then.
Well, hold on. I want to hear what you disagree about.
All right. Okay, I can't do that. Go ahead, Adam. Or so wait, who raise of hands, who agrees with Stephen's entire list?
I say it again. I think I do.
So implicit iteration, which can be rank polymorphism or something, but doesn't need to be. Literal vectors, so a way to spell rank 1 arrays, and reduce and scan.
Okay, yeah, I'm going to disagree with the second. Adam might as well.
Yeah, same here.
All right, so we'll go to Adam, Bob, and then, or Adam, Marshall, and then Bob, because only Stephen and myself put our hands up for the listener. I was thinking, as moderator of this debate, I thought it was going to be unanimous agreement. Of course, the host would think that about his own personal opinions. But anyways, Adam, you go ahead.
I mean, it's really that simple. No, you don't need a literal notation for vectors of things. If I had to construct it using explicit concatenation or reshapes or whatever, so what? It was like if I took away the list notation today from K or Q or APL or BQN or J, it would still be exact same language, except you would write every such literal list as a parenthesis with the concatenation function between the elements and done.
Isn't that the same? Isn't that a literal list though?
Yeah, well, I mean, so there's also the confusion about the literal list. I mean, I would not consider BQN's list notation to be in the same category as early APL or J or K stranding. So
Interesting. So maybe there's a
I think to the extent that you're really saying something there, it's not. And it is definitely Iverson thought that, being able to write out just the numbers with spaces was pretty important.
Wait, what? I thought Iverson was against that.
Uh,
His original Iverson notation used open paren, number, comma, number, comma, number, close paren, like that. And then when they implemented it, as I understand it and remember from people having told me, he was against removing all that syntax. And there was somebody who was very proud of having implemented the ability to write open paren, number, comma, number, close paren, and not have it be very bad performance. Because if you concatenate from the right, then you end up having to reallocate memory over and over again. So originally they did that, and then the implementers added this strand. I call it strand notation, even though it wasn't called like that at the time, but meaning just numbers with spaces in between. And Iverson was initially against that, and it caused all kinds of problems later, of course.
Yeah, I have not heard that. I mean, definitely in J. I'm pretty sure this wouldn't have happened if Iverson didn't agree with it. It has, lists of numbers, spaces in between are a single token that is. I'm not quite sure about this, but I think it's processed at the time the source is parsed instead of when it's evaluated. It doesn't matter, of course.
That depends on the implementation, and it's not that implies.
Well, yeah, but there's only one J implementation.
But this implies in other APLs where you have more generalized stranding, or even without that, even without nested arrays, the way that the binding rules are in, say, APL2 is that operators bind to their operands stronger than adjacent elements bind to each other. So that means you cannot just blanket say, oh, in this expression, it says 1 space, 2 space, 3, so it's one thing.
I mean, but Iverson didn't like APL2. So.
I don't know if he liked or not, didn't like that particular aspect of it, but it's a binding strength decision.
I definitely agree that that changing this aspect is not enough to kick you out of the Iversonian languages club. I think it's not. I mean, even if it was important to Iverson, it's not really what makes programming in one of these languages the way it is. It's not an important feature to the experience of using it.
Oh, I can quote Roger Huey, which isn't Iverson, but close. It has an Iverson number of 1, right? As saying that stranding must die, or stranding delenda est, he said. And where stranding means this thing about putting adjacent elements and that becomes a single array. Now, he said that at a time when the APL was talking about, and did not have any other array notation. So if we just followed what he said and removed that, then there would be no literal notation. The only way to have an array would be to construct it using functions. And surely if Roger says that should be removed without him saying, and we should have something else instead, you wouldn't now say, oh, that's not Iversonian anymore.
I remember this issue about stranding notation, but my understanding of it is we're not talking here about vector literals, but about the way in which, say, in Dialog APL, you can take 3 variables and make a list out of them just by typing their names together with spaces.
That's a generalization of the thing that was in APL 360. But even APL 360 allowed you to write 1 space, 2 space, 3.
What I'm challenging is the implication from what you're saying that Roger's opposition to stranding extended right the way down to vector literals.
No, he used very strong language for it, and I even suggested to him to do something like BQN and use an explicit character for it rather than just juxtaposition, and says don't give it a slow lingering death or something like that, just kill it completely. I can find the exact words.
Well, I want to toss into this because I've been on record as saying that my primary motivation for being drawn to the Iversonian language is aesthetic. Is if I have to type shit between the integers, I don't want to play.
Interesting. So I'm got to be honest, I'm a little bit confused on what we're all talking about here.
I've got my following Adam and Marshall. I think the reason that Stephen's second criteria isn't necessary is because all we're doing is determining the difference between array languages and Iversonian languages, and I think the array part of it, or the vector part of it, is implicit. So the difference between the two are the other two criteria. It's not whether you can represent something as an array. Because we're only talking about array languages, and we're only talking about Iversonian languages.
Well,
so it's a pretty clear subset.
I think it's okay to say that, like, an Iversonian, I think it's incorrect, but acceptable to say that an Iversonian language is one that presents arrays in the way Iverson designs did. So you write them out in the source code with spaces.
Sure, but we're not trying to define an Iversonian language. We're just trying to distinguish between array languages and Iversonian languages. That's my argument to it.
But array languages don't do that. Like none of Julia or MATLAB, maybe R does. I don't think so. None of those other languages let you write out an array just as 1 space 2 space 3.
Yeah, I don't think so.
Neither does BQN.
So yeah,
so here's the exact language from Roger.
Uh-huh.
So I asked him. So he wrote an email. The entirety of the email was strands delenda est. And then I said, one could imagine explicit syntax, like, and I wrote 10_20_30, which might be okay. And he answered, and his whole answer email was no. And then he wrote a follow-up email 6 minutes later saying, I mean, if you're going to kill strands, kill them stone cold dead. Don't give them a lingering death.
This is great that we're getting quotes.
This was, by the way, the last email that he wrote to me in his life. So,
wow, that is a bit more somber.
That's got weight to it for sure.
Yeah,
gravitas.
His last words to me before his death was death. Okay. Yeah.
All right. So this literal vectors literally means no stranding, no square brackets or any type of brackets, even though the other ones aren't called brackets, they're called parentheses and other things, and braces. So like, MATLAB uses bracket, number, comma, and many of the other array languages outside of the quote unquote Iversonian ones use that kind of notation for creating a list, but that is not considered a literal vector. Is that what we're kind of discussing here? Because I think earlier in the episode, I talked about the fact that, like, in C has quote unquote like array literals, but those array literals are bracket, number, comma. So like,
yeah, they're only array literals in terms of the semantics, not in
right. So there's a delineation between just basically the juxtaposition of numbers being the way that you create rank 1 arrays, and having to use either stranding or some other thing like brackets and commas, and those are the two different camps. So where does if my understanding of that is what folks were just discussing, where does BQN fall in there? Because BQN has both the sort of weird Unicode angle brackets with commas in between, and then also the bent underscores, however you refer to
the smile character.
The smile character. So like, does BQN not have literal arrays or literal vectors?
Well, other than strings, no.
So, and that informs why you disagree with point number 2 then. So Adam was, and so actually, is that the only one that folks are disagreeing with here? Both implicit iteration and reduce and scan? Everyone's on the same page about?
Yeah, I liked everybody else's things.
Okay, so it's just this literal vectors, which is interesting because I don't actually think then I sort of switched my answer because whereas Stephen said if I have to put, commas, he used something a little bit more extreme in between my numbers, I don't want to play. For me, I don't actually think, I dabble around in too many other languages that, like, I'm used to writing, in Haskell and Python and every language, basically. It's like bracket, number, comma, number. And if APL and J and these languages made me do that, I would think it's a slightly less nice, but I mean, 80% or 90% of the time, that's what I'm doing anyways. So I wouldn't, the same thing is like in MATLAB when I have to type the brackets and commas, it's like, oh, it's just like everything else. So it doesn't break my heart. And yeah, I don't think I would necessarily reject, well, because based on that criteria, we'd have to reject BQN. And I would want to let BQN through the door. So.
Oh, let me fight back on that a little,
All right.
Connor. I just left the microphone to go and see if I still have, which I don't because I've lent them to a mathematician friend, Ken Iverson's early books on elementary analysis, and which are full of the original APL golf ball stuff. And I wanted to hold them up to the camera because there's pages and pages of examples which have the numbers represented. I mean, matrices are just tables of numbers separated by spaces, and the inputs are like lists of numbers separated by spaces. And there's a beauty to it. And like you, if I had to program by putting in bloody commas and parentheses everywhere, I could live with that. Yeah, but where's the joy? Isn't it the joy that brought you to this in the first place? Isn't that why we're here doing this?
I mean, I completely agree with, the same view that you have. You've mentioned, I'm not sure if it was one episode or multiple episodes about the poetry of APL and array languages. For me, though, it doesn't extend to the literal vectors. Like, to me, the poetry is in the reduces and the scans and the outer products and even the compress. But yeah, like for me, like reduce, scan, it's the functional, generalized notation for doing all this stuff. Like, I don't want to go on a tangent, but like I've spent over the last 2 days a lot of time thinking about and sort of upset about the fact that we have in language and most programming languages vocabulary for plus reduction and multiply reduction in the form of sum and product or prod. If you're in, I think Python calls it prod. And in Q, this is a very beautiful thing about Q, adds the vocabulary for every single, or not every single, but a lot of the reduces and scans. So there's sum and sums with an S at the end, and purd, because they drop the O, and purds for product. And they have min and mins. And anyways, I won't go on. But I realized, and I guess this is becoming a tangent, that there's an NVIDIA library called MATX, and they call their max reduction Rmax, and their min reduction Rmin, because the vocabulary for sort of naming a reduction, for plus reduction, it's sum, for multiplies reduction, it's product. But then for every other reduction, there isn't really a name. And it's the same irritation of why we gave infix binary operations to plus, minus, divides, and times, but then stopped at min and max, and we then have to use prefix named functions. And so this is what I've been dealing with, is do I want there to be other shortcut names? So like, do I wish there was something like, Cain and Abel for like the min and max reduce? Like sum and product, sure, it comes from language, but like there's not really any in the names of plus and sum. When you look at the characters, it's like there's no real relation there other than like how language evolved. And I just wish sum and product like didn't exist, because then I wouldn't feel bad about the fact that there's no name. Like, because then it would always just be like plus reduce, times reduce, minus reduce, and it'd all be regular. But because sum and product exist, and actually in most languages that don't have 2 characters for a sum reduction, having a 3-letter function in the name of sum is very nice. It then makes me think, well, what should we call the min and the max reduce? Haskell calls the minimum and maximum. This NVIDIA library just prefixes an R. And it's frustrating. This is my 2-minute tangent of there are no specialized names for these other reductions, and I don't know what to do. And like, what I really want is I want the words sum and product to disappear for our vocabulary, so we could all just be having like the reduces, which is what you have in APL, and that's why it's so beautiful. Everything is 2 characters. It's the binary operation and the reduce, the binary operation and the scan, and it's even nicer than sum, because the reason that I really like sum is it's so terse. Switching sum to reduce parentheses, and then your binary operation plus end parentheses. It is nicer to type sum, and so you don't actually want to get rid of it. And everyone coming from Python knows that there's sum there, and so they're going to be irritated. Why do I have to spell reduce? Anyways, Bob had his hand up, and I'll stop my tangent.
Well, one of the things that I've heard Henry Rich say, I think he actually wrote it down somewhere, was the fact that J is a bit like a plumber's toolkit, where you have connectors and you got pipes, and the pluses would be like the operators. The verbs essentially are the pipes, and the conjunctions and adverbs are the connectors, and you can connect them all in different ways. So in essence, what you're saying about your sum is, in J, I think the way quite often people think about it is that you break it apart and you think about them that way. So it's plus slash. And that's what you do for summing. You don't call it sum, because that creates problems for all the other ways you would use that slash. You just say it's plus slash. That's the sum. That's what you read it as when you do that. And so I'm kind of on the same page as you with that, I suppose.
The problem that I have is that like Rust and Python and all these languages, they have sum, and so like and spelling it out literally is more verbose and kind of irritating. And so it's just that's my wish, is I wish sum just didn't exist, so that the people from Python and Rust aren't like, how come I have to be more verbose when I come, even you don't in J and APL. Sorry, I cut you off, Marshall, though. What were you going to say?
Yeah, so a strategy that I really like for these non-Iversonian languages, where a function can have any number of arguments. Obviously, this doesn't work if functions can't actually have any number of arguments, like a lot of languages do, like they limited it, some large number. Is to say that the plus function actually doesn't take two arguments, it takes any number of arguments, and it just adds them all together. So actually Lisp does this.
Yeah, Lisp does that. I was actually thinking about this.
And then, you would have the same thing you have in K, where you would have some special way of applying the plus function to this list, and it would add all the numbers together. And then you could do that for min and max and all the things. And you could even do it for minus, and that would make sense. So then you're saying that, well, this plus reduction is not really even like, you don't necessarily want to express it as a fold. And what that also lets you do is you don't have this strictly imposed argument ordering that we've been talking about, where you have to sum in a particular order, and then the language can do like, a binary sum that's faster. So that's a nice strategy that would is a different way of sort of unifying, making all these reductions easy to write.
So that is actually something that I thought about, and it ties back to something I had I don't know if it was a year ago or months ago, that Lisp's, like if you think about, I think about sort of the four main higher order functions are reduce, scan, map, and then technically there's find. But actually, I might be getting the fourth one wrong. But anyways, you've got reduce, scan, and map. And map is kind of implicit in array languages. Like that's the implicit iteration. So you never need to spell out map. Technically, there's each, but we'll ignore that. And so like a key feature of these languages is that the map higher order function is implicit. And this isn't the case for Lisps, but you could think of, what if you change the higher order function that was implicit in your operation? And so instead of mapping, so like when we do, adding to matrices or whatever, we just put plus. But like, imagine if instead of that, we were doing reductions implicit, which is kind of what Lisp does in certain cases, which is what Marshall's talking about. You don't actually have to mention the reduce. You just give it a number of arguments and it'll do the reduction by default, which I think in some Lisps you have to do like an apply plus. Others you can just go plus and then either two numbers or a list of numbers. And that fixes my problem, is because now I don't even need to mention reduce. It's called,
How do you do scan then?
Well, scan would be explicit once again. But that thing is that we don't actually have names for scans except for in Q. And Q does a very beautiful job of naming them by just adding the S. But like, I don't have the problem of sum. Like sum it's really problematic. Product is not as much because it's 6 characters. And you think, well, it's still a pretty short number of characters. But like the difference between like reduce mul and product and like reduce plus and sum, it's like a factor of 2. And sum is really the problem. But the point is that we don't have a vocabulary for scans. So the fact that I still have to be explicit about my scans solves my problem. The point being, though, is I think that like in order to get implicit reductions means that you have to give up implicit iteration, aka mapping, which I don't really want to do.
No, I don't think so. Because like if you have the function plus that takes any number of arguments, That's just all the arguments it takes. And each one of those could be an array. And then it would figure out, what's the common array structure of these.
I mean, let's say we didn't have this overloads that are common in Iversonian languages,
Yeah.
which, hey, maybe that's another criteria. Overloading monetic dyadic on a single symbol. Q has something to say. But let's say we didn't have that with separate symbols. And so you just define the plus symbol. If you only give it one argument on one side, then it's a sum. And if you give it two arguments, then it's plus.
My mind is like blowing right now.
So then if you would write minus 10, 1, you get 9.
So actually, that's wow. All reductions.
Or we could say you can translate any infix operation to a reduction over the concatenation of the arguments.
So wait, why? This is. I'm missing something here. Why do we need the? That's a great point, Marshall. So you said, wow, I'm not sure. We have to figure out if it's a great point. Seems like a great point at the moment. Why do you actually need this? Like, what's the purpose of the slash? Why not have exactly what I think Adam was just saying, is that in APL, instead of going plus slash on an iota sequence or a list of numbers, you just go plus, and that sums everything up. And then when it's infix, in the binary case, where you would have mapping, and in almost all situation where you're doing rank polymorphism mapping, you either it's in a binary case. You've got either a scalar in a matrix or matrix in a matrix, etc. So why is the slash there? What is the slash giving you? What is the reduce giving you there?
Well, it explicitly tells you this pairwise order, but I don't think anybody really cares about this pairwise order. It's actually a pain when you're when you have a float array and you have to go in order because that's slower.
Oh, so the type of reduce, the direction you mean?
Yeah.
So like the fact that it's the slash means a right fold, or it could mean left fold, or it could mean a non-deterministic reduce.
I mean, it does break it down into this individual, a binary operation. Because, I mean, really, you can only implement, like, you have to first define what the sum of two numbers is in order to define the sum of many of them. You could go straight to an array, but that's kind of artificial. I mean, you'd basically be defining a reduction and building it into your definition.
If you didn't want to use the reduction, I think you'd still have to do it with rank, wouldn't you? You'd still be applying. So if you had a list of numbers and you say put the monadic plus, which is sinum in J. If you want to, if you didn't have a reduction, you'd still need to do rank 0 so that you could do sinum to each individual one, because otherwise you'd be doing rank 1 would sum up the whole list. You still need to specify rank, I think.
Well, the default would just be full rank, which is usually what you want.
I mean, that's rank.
Yeah, well, it's weird with multidimensional arrays because,
yeah.
And if it's a scalar function, then it would apply
I think
to each.
Rank would still be fine on both of these cases.
And this again, we have to get rid of the overloading, pairing up monetic dyadic forms in order for such a thing like that to work.
Yeah, well, and not being able to write, minus X to negate X is pretty annoying. Now, people are not going to like that. So,
is that any worse than not being able to write -5 to mean -5? You have to write either high or low minus in these various languages.
Well, you don't have to.
All right, we'll come back. I got to think about this for like 2 weeks. We're totally.
Yeah, well, this is non-Iversonian discussion.
You said something that's like broken my brain, is that, and we will come back. I promise we will talk about this in the future, about a language that replaces the overloading nature of, two different meanings for the monadic and dyadic case of plus to just, in the dyadic case, implicit mapping, in the monadic case, implicit reduction. We'll revisit that, put a pin in it. Back to Stephen.
Let's see if I can help get this back on track. I would like to take 2 items from Marshall's list and add them to mine. One is the outer product, and the other is the reduction, compression, the wear.
Mm-hmm.
And are those uncontentious? Can we vote all of those in?
Yes.
I mean, K doesn't have. Marshall did say an easy way to do outer product. KQ don't have a built-in, but
yeah, they do.
You need with a couple.
Well, so they both decompose outer product and the and the compression. I would say that they do this in a fundamentally Iversonian way, so it's not really.
You can do an outer product in Q. I mean, it doesn't look the same, but
Of course you can do, but there's no
yeah.
built-in.
I mean,
for
it looks like a built-in to the uninformed, which is basically me when it comes to Q. Is that like I spelt it wrong one time and then someone corrected me, but by combining
well, it's just each left, each right for all the listeners who are pondering this.
yeah. So that was the thing, is I had just done one of the special cases that it just happened to work, but then someone pointed out that technically an outer product you need to do the /:/, and then put your binary operation on it. But I mean, yeah. So I vote that all of those two things are unanimously in to other people. We got Bob's hand up.
You can't vote for them to be unanimous.
Adam and Marshall refuse to be.
No, of course.
I took them from Marshall's list. It had to be.
No, I'm fine with the criteria, but having a very easy, straightforward two built-ins in order to do it instead of one built-in, just to get Q and K along, since they don't have a compress and they don't have an built-in outer product. Yeah.
Oh, do K and Q not have compress?
Q has where, and the K form of it is the ampersand.
Well, Q actually has the name where, doesn't it?
Yeah, Q has the name where, the keyword where, and the K form of it is the ampersand. So it's the monadic ampersand.
All right, I'm gonna as moderator. That seems like a unanimous enough agreement. So we're getting there. Implicit iteration, reduce scan, outer product, compress with a list of booleans, and we're way over here. But I did want to. I mean, I said I was gonna skip Marshall's initial thing, and then skip Adam's thoughts on Stephen's literal vectors, and then I was going to go to Marshall's thing. So the other two, and maybe because we're short on time, we'll just talk about the second one. Mainly symbols for array operations. So does that mean Nial gets cut? Because right now Nial's in the party. Nial's partying with the other array languages, but Nial doesn't have any symbols as far as I know. They're a completely...
Yeah, that's a good question. I mean, I feel pretty willing to throw out Q because it does. I mean, it's clearly an attempt to make the Iversonian languages more, easier to work into for people with other experience by making them less Iversonian.
So you want to throw out Nial and Q?
I don't know if I can throw out Nial. And I don't know a whole lot about it as a language.
Like Bouncer Marshall just standing at the front of the party and just not only not letting people in, he's going in and kicking people out.
Yeah.
I mean, this is a bit.
I think it's an interesting conversation. Is that like
So yeah, to go back to my definition of an Iversonian language is one that's primarily influenced by Ken Iverson's ideas. Is that really true of Nial, or is it? Now, the weird thing with Nial is that it doesn't take a lot of outside influence, but it's influenced by APL and also Trenchard Moore's ideas and some other person who was involved in creating Nial. So it's there are definitely a lot of new things there. And I could ask about my own language, I, in a similar vein. Like the main influence on I is definitely J. But I did a lot of stuff in I completely changed the syntax around. The functions are written with letters instead of characters and all sorts of things like that. So I don't know if I really is Iversonian anymore, or if it's, just some weird branch hanging off in space.
So if you are listening to this and you're a Nial expert, I've interacted with some folks on the APL Farm Discord. We will bring someone from the Nial community and we'll get educated by them. But like from my dabbling around in Nial, it like conforms very closely to APL. I don't know much about the are they called?
But that's in terms of the semantics, right, and not the syntax.
So that's the thing. It's very similar in spirit in terms of like down to the way that scans work, which I consider them broken. It like copies and rank and everything that I can do basically for simple LeetCode problems translates perfectly to Nial. But it's just that everything is spelt with, what do you call them? Function names, or I don't want to call them keywords, but and they might be keywords if they're in the standard library. Everything, iota, instead of an iota symbol, they have count, and instead of, the slashes for reduce and scan, they've got accumulate and reduce, and it goes on and on. So then, and I do, like I think Marshall mentioned, there's a couple extra ideas. I think they're called function trains, or however they have a way of chaining functions.
Oh, they have atlases.
Atlases is what they're called. Thank you. Yeah.
Which are lists of functions. Although these are actually very similar to function arrays in Dialog APL, except it's more like an integrated part of the language, so they're easier to create and use.
Yeah. So we'll have a NEAL expert on, and they will also correct if our pronunciation is incorrect. But so the big difference is just it's the words, and similar to Q, it's just the words, and it's like, does that change? Because a lot of folks that I've talked to, they will argue that sort of tool of thought and the mnemonics of the symbols and stuff disappears, even a little bit to an extent when you're dealing with J. And so, like, I'm sure there is a camp of people that believe that as soon as you add words and you're no longer dealing with a quote unquote sort of symbolic language or notational language, it doesn't count. Anyways, Adam's got his hand up. We'll go to Adam.
Yeah. If I remember right, I grew up on APL Plus, and at least there was some version of APL Plus that I used that had an option you could switch on and off to expose English names for the primitives. Okay, so if you switch this option on, then you could write reduce first or something like that instead of /bar. Surely you will not say that if I'm in the middle of my programming session, maybe even suspended in the middle of my function running, and I switch this option on, now I'm not using an Iversonian language anymore.
I mean, I think some people would. Some people would, though, I think. And sorry, I cut you off, Marshall. What were you saying?
It does have the symbols, right? It just adds names.
Yeah, but and then if you look at very old like mailing lists and things for APL, then because of encoding issues, then they would spell out primitive names in braces. Braces weren't really used for anything, so they would spell them out or kind of picture them with ASCII characters. Like, surely, if you spell out, or you could say it like this: if I take some APL code and I read it to you in English, is my spoken form of the written code not Iversonian, while the written code is Iversonian? Seriously, give me a break.
But that's the thing, is it's like you are losing information by changing the mode of communication. Like, to say that there's absolutely zero difference is like demonstrably false. Like, the visual representation of some of the glyphs is lost when you say the word. Like, how many times have I talked to, or I brought this up in talks that I've given, but like the fact that reduce and scan or fold and scan have, in the spoken version or in the written version, when you spell out reduce and scan, have nothing to do with each other. But the way that I discovered the relationship between those two algorithms or functions is that they're vertically symmetric when you're dealing with the slashes. Like that eureka moment, or like the discovery of the relationship between those two algorithms, came from looking at what they visually look like. So there definitely is a difference between saying plus scan and plus reduce and looking at the plus slash and like plus backslash. Like, it's even in trying to,
I wouldn't read them like that. I would say like Bob. I would say plus slash and plus backslash, and you can hear right away that they're related.
but that's actually not how. Is that? I think most people say plus reduce and plus scan. Like
I don't. I say plus slash for sure.
Well, we got to get a Twitter poll going on here of how do you read the following in an APL speak or BQN speak or J speak.
Well, I mean, that is part of the thing about APL is that when people speak APL, they say, wildly differing things for the names of different functions. Like
almost nobody says index generator. Everybody says IOTA.
Yeah.
I want to weigh in on Connor's side of this. When I was revising the Q reference, I found that earlier versions of the documentation spoke about scan and over, which is reduce, documented them separately. And actually, it's the same computation going on in both cases. So it makes it's a little tricky in terms of typography and writing the articles, but they're now, I think, properly documented as basically the same thing. And it's just a question of whether you want all the interim results or just the last result.
Yeah.
Who doesn't say jot dot times?
I don't.
Well, I would usually say times table, but that's because I use it.
You don't say jot dot times when you read it. What do you say?
That actually depends. It's like sometimes you read it literally as like the jot dot, but like usually, well, yeah, it depends. Sometimes I say outer product. Sometimes I think the meta point, or the point that I'm just trying to make, is that like there is a difference between having words, and I don't even know what camp I am, because like for me personally, I think like the true authentic, array language, Iversonian language experience is in this like symbolic, it's looking at the symbols, it's even to J, like you lose something. And so I think that's the purest form. But like once I've been swimming enough in that like Iversonian lake of ideas, it's like it's me going to Q or to J or to even Niao. It's like I already have learned like the purest form of that, and now I can just solve problems that way, and however I spell it doesn't really make a difference. But being like indoctrinated, or like, falling, like learning it through a language like Niao, I don't think is going to have the same impact, because, they call their scan accumulate and they call their reduce, and like you're not going to have some of the same insights. And even when it comes down to like a lot of the operators, I think in APL, they use like the diaresis, or however you pronounce that. So like the fact that, the W combinator, which is, I think, referred to as self, some people call it selfie, it's got the double dots over the complement. And like even there's some like symbolism in there, and that like the complement is sort of like the flipped whatever. And it's like there's so much beauty in all these glyphs that gets lost when you wordify it. And that's not to say that we don't let the wordified languages into the party. I think those languages should come into the party. I just think there's even like a small... Sorry, go ahead, Marshall.
In terms of letting things into the party, I think we have all these criteria now, but we have to admit that, if you miss one or two criteria, even if you do it pretty badly, I mean, you're probably still an Iversonian language. Like, so even if you took APL, if you took exactly APL, the language, but you scrambled all the glyphs, you assigned each one to a random Unicode character, we'd have to say, I mean, yeah, why did you do that? But
that's BQN for you, right?
No.
No, I'm joking.
No, it has a lot of characters in common still. I mean, most of the changed characters are actually for substantially different functions.
So can we let them in, but let them sit in the back of the...
No, so this is exactly my analogy, is that inside the party, it's a club. I was picturing it like a house party, but it's not. We're at a club, and there's like a VIP booth where, they got to let you in, like the little sash ribbon. Oh, yeah, they're allowed in. So now inside our circle, we have an even better circle, which I don't know who's in that circle, but...
right in the middle, you've got to have the ones that Iverson literally made himself, right? They're sitting in these red plush chairs.
Well, so now here's the question is like, does J even qualify with the digraphs? It's like now we're getting into like the version of this argument.
Yeah, because I mean J's kind of far from APL. Yeah.
Yeah.
Jot dot is two characters.
No, but that's okay. That's for another episode. Why that is? It does have a real reason for it. Actually, the more I explain it to people, the more I kind of feel comfortable just keeping that around. It has a good reason. But you know about the controversy that was at the first APL conference when J was presented?
Yeah, I think we covered this, and I put it in the show notes of my other podcast. I think I found there was no slide deck, but there's a paper that was attached to it, right? The APL / ? Or whatever. Is that what you were going to say?
Yeah, but there was a whole large group of people in arranging or at the conference that basically didn't want Iverson to present.
Yeah, that's sad.
This, saying this doesn't belong at an APL conference.
Yeah, but they weren't arguing it wasn't an Iversonian language. They were arguing that it wasn't APL.
I mean, I think it was kind of the same. APL and Iverson was the same, and I think Gitte Christensen, the CEO of Dialogue, she mentioned she was there, and she said like this is ridiculous. Anything that Iverson has to say belongs at an APL conference. So basically, she's redefining APL conference as Iversonian conference, and by definition, whatever Iverson has to say belongs there.
Yeah,
which means J is definitely Iversonian.
Well, did anybody argue that J wasn't actually created by Iverson? Like some sort of Iverson was actually killed off and some duplicate was brought in.
I was going to say, are you like putting forth like a Ratatouille? Like there was some Marvel alien with...
I'm just saying, many people are saying this kind of thing, that perhaps there was a conspiracy to actually create an array language that appeared to be made by Iverson, but it wasn't.
Oh, God.
I want to pick up on a point that the Connor was making about the difference between using symbols and using English names. When we translate poetry from one language to another, you have to pay a lot of attention to the associations of a word. So it doesn't do just to pick a word from one language and find its exact equivalent in another language. You have to think about the associations, because the original poem is bringing in and pulling on all of those. When I'm reading program code, English words spark off all the associations they have in my language, and which have generally very little to do with the programming problem. So when I'm reading symbols, I have this experience that I'm focusing tightly in on the problem. This extends to my choice of names for variables. I try to avoid mostly avoid using English words, because I don't mean the thing that the English word means. I may mean something like it, but I mean only explicitly what I've defined it to be. So I might use, I commonly use, say, an acronym. I might put in the comment, things waiting to be processed, and the variable name will be TWTB. Like that, just enough to refer back to the original comment, but not enough to kick off that train of associations that comes when we use words from a natural language.
Yeah, I mean, that's a great analogy. The poetry one is that if you listen to, I'm not a poet, but if you listen to poets talk about translating, is that it's people will say that there's always something lost. Like if you're translating, Russian poetry into English, and that like in order to really appreciate the poem is you need to not only just speak the language, but like you have to be fluent enough to understand those word associations, and the depth of the poem is going to be lost to a certain extent when you translate it into a different language, which I think is like a perfect analogy. It doesn't mean that you're not reading quote unquote the same thing and you can't understand it, but there is some extra meaning that gets lost when you go from the symbols to the wordified versions, and that, that's a very apt analogy.
Yeah, I can say my linguistic, unless in like, at least in like English or whatever the human languages, center of brain and consciousness is not at all present when I concentrate on APL code. Things go directly from symbols to meanings, concepts in my head without speaking it out.
Now you're reminding me of an essay by the late American humorist P.J. O'Rourke called Ferrari Refutes the Decline of the West. It's an essay in which he describes driving a Ferrari from the East Coast to the West Coast of America. When he gets into the Rocky Mountains, he says, there we found that the steering was frighteningly direct, straight from the left brain to the road.
Bob, I think you were trying to say something earlier too, and it might have got lost in the commotion. Do you recall? No?
No, I'm lost in the commotion. Actually, I guess one of the things is it was remarking on Marshall's idea of a conspiracy theory for the origins of J, and I thought, I didn't start out trying to make conspiracy podcasts. I really didn't try to start out making conspiracy podcasts.
Yeah, and that's what it's become. I feel like unless if there's any last things we want to say, because we've way blown by the 1 hour mark, as if anyone has made it to the end of this podcast will know. Are there any last comments we want to say? Is there going to be a part 3? No last comments. So I feel my general sense actually is that the difference between array languages and Iversonian languages, like it's interesting that a lot of this stuff is, specific to, or the conversation has been around spelling, or, this one function existing. And, I suggested minus scans, there's outer products, reduces scans. Like, I don't actually think the delta between the two is maybe as large as I had originally thought in my head. And it's more, I don't want to say like ethereal, but it's more like style, the way it makes you think. At least that's the sense that I'm sort of, the fact that a big chunk of this was a discussion on symbols is I think, an interesting artifact of this conversation. And I'm sure there's actually some folks that are probably listening to this and being like, why are these 5 individuals spending so much time talking about stuff that just doesn't matter? Like, I've met people that
they don't know us at all.
Yeah, they're just like syntax versus semantics. Like, I definitely know, because Aaron Chu, I think, in his a couple of talks, has talked about the importance of syntax. And there are some people that think that syntax is absolutely like meaningless. It's just semantics is all that matters. How you spell it means absolutely nothing. Like, why are we spending discussion on the way that we're going to spell this? And I think it seems to be a trend is that folks that have spent time in the array languages definitely care about syntax and the spelling of things. And that, as we were just discussing, like, you can lose meaning in the syntax that you choose, which maybe doesn't impact semantics. And arguably you could say semantics are more important at the end of the day, but that doesn't mean that syntax is completely meaningless, especially at the point where you're dealing in Unicode symbols and you can have insights because of the way that these things are visually represented. But anyways, any last thoughts folks have that want to share?
I'm just curious, if we now go through all these criteria, and I might be mistaken, but does the Wolfram language not end up being Iversonian then?
Oh yeah, that was one we didn't get to talk to. I mean, I feel like we should.
What is it missing?
Well, it doesn't fit the syntax.
You said it has to have infix and prefix syntax. Well, it does have those.
So I meant that was the for every function. I didn't say that, but
wait, but that even
like that should be the way you call functions, not because a general function in Wolfram language you'll call with square brackets, right?
Okay, but that's then Q and K out.
They could be.
We have determined that Marshall is the official or unofficial bouncer of this club party. That, you know.
Yeah, well, so Q and K, you can write a function application.
Oh well, I've got to jump in on this point. In that case, I can entertain an argument that Q has strayed too far away from the Iversonian principles, but I happen to know that Arthur Whitney is Iverson's spiritual heir. I've seen the robe and the bowl, and the sandals.
Oh,
and
no.
I think any criterion which excludes K is going to be seriously
Well,
problematic.
it can be an Iversonian language then.
An Iversonian.
That's circular, no?
The story continues.
Marshall's the bouncer, the conspiracy theorist, and the creator of.
You heard it on this podcast first. This new term, coiner of new terms of programming languages. Now Wikipedia needs a Iversonian category for programming languages.
Yeah, but in terms of the syntax, why I was actually a little surprised to be the first one to bring up that kind of syntax criterion. I think I don't want to say that, the more Iversonian a language is, the better. I don't think that even about BQN. But you have to say that to the people who are programming in Iversonian languages, the syntax is very important, and that's what kind of makes this family of languages special in a way. So as a distinguishing feature, yeah, you do have to point to the syntax as one thing that makes this family of languages what they are, even if you think that, all that you should care about when writing a program is the semantics.
Yeah, I think what I'm going to do, similar to the last conversation that we had where I made up that Venn diagram, I'm going to create a markdown file that has this list of stuff on the left, or maybe at the top, and then the list of languages on my array language comparisons repo.
Table.
And then, a table with, little greens and reds, hearts for which ones have this, which ones don't. And then we can stare at it next time. We don't need to necessarily dedicate a whole episode to it, but I think it would be good to talk about the prefix infix one, because that's also something that we didn't spend a lot of time on or any time on. Yeah. And then we'll have a discussion, and we'll get a full list of we'll go through and raise our hands, and then we can get a tally of which of us think each of these criteria and should be or should not be included, and also too what is the result? Does Q make it in at the end of the day to the party? Does Niall make it into the party at the end of the day? And then maybe somehow we can release it out as not maybe a poll or a survey, but it will be
As
curious.
a mug.
What?
As merchandise.
No. I was to getting people's feedback of what the greater community at large, how they feel, because as I think I mentioned this before, but yeah, I've had conversations about what makes a language functional, etc. And one of the responses I got was like a lot of it is defined by how the community uses it and views it. Is that you can have a functional language, but if it's not idiomatically or commonly used in a functional way, if there's a way to get at side effects and that's what commonly is being done all the time, then it's makes it less of a functional language because the community doesn't use it as a functional language. So
well, and that's the thing about Wolfram language. I mean, yeah, it fits most of these criteria because it fits almost every criterion. It just has so much stuff packed into it. I think it might not have the compression thing where you're filtering an array by a Boolean list, although I'm not sure about that.
Come on, it's got 6,000 functions.
Yeah, so it might have a function for that. If it's not written with a symbol, I think it doesn't. It's not so good. But then Q doesn't meet that one either.
All right, stay tuned, listener or listeners. Haven't made up my mind how to refer to the listeners, but
you have to call them listeners because there aren't one of them. There are zero. At this point,
we will have a follow up. Either half an episode. It'll probably, let's be honest, it'll probably end up being a full episode because here I am saying, it'll just be 10 minutes and this was supposed to be an hour and we're closing in at like the 2-hour mark at this point.
Oh no, let's not go there.
And at contact@arraycast.com if you have an opinion on this, and I'm prepared to be flooded with opinions.
Yeah, if people have made it to this point in the episode, this might be our longest episode at this point.
This will be our longest episode.
Yeah. Well, we should encourage people to send in additional criteria, inclusion and exclusion criteria that we might not have thought of.
Yeah. Well, so if by the time people are listening to this, I will have made my markdown file. You can find it in the show notes, and if you're GitHub savvy, feel free to make I will put a section for proposed criteria by the community, and you can open up a pull request or even just leave an issue or a comment, and I can add them, and then maybe we'll bring those up in the future discussion, part 3 of this. Yeah. This has been fun. My brain's been broken. I got to go and think about some things. And either we'll be doing this again in 2 weeks or maybe we'll have a guest. Stay tuned. And I think with that, we will say happy array programming.
Happy array programming.